Welcome to The Explainer. Today, we're soaring straight into the fascinating, incredibly high-stakes world of aviation meteorology. Look, whether you're an aviation total nerd, a student pilot, or just someone wondering what actually goes into keeping a 300-ton metal tube flying safely through the sky, this one's for you. Because weather, it isn't just small talk for pilots. It is literally the ultimate deciding factor for every single flight plan. So we're going to break down the exact notes, the codes, and the charts that professionals use to navigate the skies every day. All right, let's kick things off with something every single pilot absolutely loves to see on a report. KVOK. It literally stands for Ceiling and Visibility OK. When this code pops up, man, it is a breath of fresh air. It specifically means there are no clouds below 5,000 feet or below the highest minimum sector altitude, whichever is greater. And most importantly, zero cumulonimbus or CB clouds anywhere in sight. It's basically the aviation equivalent of a perfect, clear, sunny day. But since we've started with some optimism, let's look at how we navigate when things aren't quite so perfect. So here is our flight plan for today's explainer. First up, airport weather basics. Then we'll move into reading the weather charts. After that, spotting the danger zones. And finally, we'll wrap up by looking at the future of forecasting. Okay, Section 1, Airport Weather Basics. Let's look at local weather conditions. When looking at immediate localized weather around an airport, crews are analyzing these reports before the plane even thinks about pushing back from the gate. First, you've got your METARs. These are routine reports issued every 30 minutes giving you the exact current on-the-ground conditions. Then you have the trend, which is super useful. It's essentially a quick 2-hour forecast tacked right onto the end of that METAR report, so pilots know what's coming next. But hey, weather can turn on a dime, right? And that's exactly where the spec sheet comes in. A spec sheet is a special report raised outside of that 30-minute window, specifically to alert pilots to sudden, critical changes in the weather. Now, here's a massive quirk you kind of have to know about how wind direction is communicated. There's this golden rule of thumb in aviation: everything the Met man tells you is true. What that actually means is when you're reading a written METAR report, the wind direction is given in true north. But if you're listening to the ATIS audio broadcast or talking directly to the control tower, the wind they give you is oriented to magnetic north. It sounds like a subtle distinction, but when you are literally lining up a jet on a runway, knowing exactly which north that crosswind is coming from is absolutely crucial. Moving right along to Section 2, reading the weather charts. We're zooming out for the macro view and SIGWX. Okay, so zooming out from the local airport, take a look at these surface lines. These are essentially the secret code of mean sea level, or MSL, pressure charts. To most of us, it just looks like geometry, right? But to pilots, it tells a highly dynamic story. See the line with the solid triangles? That's a cold front at the surface. The one with the semicircles? That's a warm front. Now, when you see a line combining both those triangles and semicircles pointing the exact same way, you're looking at an occluded front. If they're pointing opposite directions, it's a quasi-stationary front. Oh, and you also have to watch for these exact same symbols drawn with a little empty gap at the bottom. That indicates the fronts are active up above the surface level. Now, when we get up to cruising altitudes, flight crews rely on high and medium-level significant weather charts, or SIGW for short. These are typically prepped 24 hours in advance to show conditions at main synoptic times: midnight, 6 a.m., noon, and 6 p.m. UTC. But here's the clever part. They aren't just frozen snapshots of a single minute. Each chart actually covers a window of 3 hours before and up to 3 hours after its issue time. So a 1200 UTC chart is totally valid from 900 all the way to 1500. And the geographical coverage of these charts, it's not random at all. It's strictly determined by regional air navigation agreements. There is just a massive amount of data packed into these charts using some pretty wild symbology. Just look at the jet stream markings. A wind arrow shows you the max wind speed and the level it's running at. A solid black triangle on that line, that indicates 50 knots of wind. A single line is 10 knots. So 2 triangles and a line, boom, that means a roaring 110-knot tailwind, or a really bad headwind. You're also going to see severe squall lines marked with crossing check marks and these widespread scalloped edges that warn of dangerous conditions ahead. There's even a very specific symbol just for volcanic eruptions, which triggers immediate warnings with exact latitude and longitude coordinates. All right, Section 3, spotting the danger zones. Let's talk about cumulonimbus and major flight hazards. Out of all those hieroglyphics we just looked at, there is one specific weather phenomenon pilots try to avoid at literally all costs: the mighty cumulonimbus cloud. When these are forecasted, the charts use 3 specific codes to tell pilots exactly how densely packed they are.
Isol means isolated. You're dealing with individual, isolated cells. OCNL is occasional, meaning the storm clouds are well separated and a pilot can usually navigate safely around them. But FRQ, that means frequent, and it is a nightmare. It means there's little to no separation between the clouds. Trying to find a safe path through a frequent line of storms is incredibly difficult and honestly really dangerous.
So here is the absolute bottom line. The mere inclusion of the letters CB on a chart is a massive glowing red flag, period. By definition, seeing CB guarantees that severe weather is present. You aren't just dealing with a little rain here. You have to assume the presence of thunderstorms, moderate to severe icing building up on the wings, moderate to severe turbulence that is going to violently rattle the cabin, and potentially catastrophic hail. If you see CB, you respect it and you route around it. No questions asked. And finally, Section 4, the future of forecasting. We're looking at the digital WAFS evolution. Aviation meteorology is going through a total revolution right now in how global data is managed. For decades, the industry relied on legacy forecasts. These were the T+24 paper-style charts that just gave you a static snapshot of a single time, literally hand-drawn by meteorological teams in the US and the UK. But the new standard is the Digital World Area Forecast System, or WAFS. Instead of a single static picture, we now have automated multi-timestep forecasts provided entirely in a digital format. They project out from 6 hours to 48 hours at 3-hourly intervals, pumping out fresh data every 6 hours. It is a completely dynamic, constantly moving picture of the atmosphere. And because we've gone fully digital, the new WAF system introduces some incredibly intuitive color coding for hazards, which thankfully replaces a lot of those older black and white hieroglyphics. On a modern display, gray means turbulence, with dark gray signaling severe turbulence. Purple means icing conditions, again getting darker based on severity. And our old friend, the cumulonimbus cloud, vividly marked as red scalloped areas. It's so much faster for a pilot to just glance at the screen and instantly spot the hazards. So what's the actual real-world payoff here in the cockpit? Let's break it down. Step 1, because this is fed through digital APIs, it integrates directly into the plane's flight management software. Step 2, pilots can now toggle and filter specific weather layers. You can literally turn off the icing layer just to focus on the turbulence. Step 3, it shows the actual movement and evolution of weather features over time rather than just a frozen snapshot. And Step 4, this drastically improves planning for long-haul flights, giving crews way more relevant data for every specific phase of the trip. It's safer, it's more reliable, and it's incredibly precise. Which brings us to one last kind of provocative thought. We are leaving behind hand-drawn paper charts for these ultra-sophisticated, API-driven automated grids that map the skies in perfect digital layers. Obviously, it's an unbelievable leap forward in safety, but as these machines and automated forecasts predict the skies with such cold, calculated precision, what actually happens to the traditional human intuition of the pilot? Does the art of reading the sky eventually get lost to the science of reading a screen? It's something every new aviator is going to have to balance. Thanks so much for hanging out with me for this explainer. Keep your eyes on the skies, and as always, safe flying.